Hello, let us study what is the torque experienced by a current carrying rectangular coil placed in uniform magnetic field. Before going to this, let us recollect what is Fleming's left hand rule. This is the rule for finding the force experienced by a current carrying conductor which is placed in uniform magnetic field B. The rule states that if we stretch our forefinger, central finger and thumb of our left hand in mutually perpendicular direction, if forefinger indicate the direction of magnetic field, central finger indicate the direction of current, then thumb indicate the direction of force experienced by the conductor in the magnetic field. Now, this is just a coil and this coil is carrying current I, and this coil is placed in magnetic field produced by two bar magnets. We just imagine it's a uniform magnetic field. That is, the current carrying rectangular coil is placed in uniform magnetic field. Now, if we keep the coil this way, we can see the coil experiences a torque and due to that it rotates. Let us see what is the torque experienced by it. For calculating, we just imagine the same case. This is pole piece, another pole piece of two magnets. So from this it is very clear that there is a magnetic field acting from north to south. In this direction, a magnetic field B is acting. In this magnetic field, we keep a rectangular coil. This is just a coil, rectangular coil, and that is carrying current. Now, the coil is carrying current I. The coil is carrying current in the anti-clockwise direction here. And we name the coil as A, B, C, D. So the coil is A, B, C, D, A. It's a rectangular coil. Now look at the coil. We can imagine this coil to be made up of four equal parts. AB is the conductor, BC is another conductor, CD is the third conductor, and DA is the fourth conductor. So it's a combination of four conductors. Now look at AB. AB is carrying current in the forward direction or in the upward direction. So what is the force experienced by AB? According to Fleming's left hand rule, we can write force experienced by AB is equal to I, let its dimension be L, breadth is B. Similarly, rectangular coil. So this is L, this is B. So force experienced by AB is I, L, B. Theta is the angle between I and B or L and B. So here angle is 90 degree. So ILB sin 90. And we know sin 90 is 1. So we write ILB. According to Fleming's left hand rule, this force is experiencing, just look at, forefinger is indicating the direction of magnetic field, central finger is indicating the direction of current, hence AB experiences a force towards the plane of the screen. So we can say this AB is experiencing a force towards the plane of the board. It is experiencing a force towards the plane of the board. So that is indicated by this arrow. I just write it as FAB. So this is force experienced by AB, which is towards the plane. Now similarly, force experienced by CD, magnetic field is same, current is in the opposite direction, hence definitely CD is experiencing a force away from the plane of the screen. Similarly, look at BC. According to Fleming's left-hand rule, forefinger is field, central finger is indicating the direction of current. Hence, we can see this piece of conductor, that is BC, is experiencing the force in the downward direction. Look at DA. So DA is experiencing force in the upward direction because BC and DA are having same length, but current is in the opposite direction, and we can see these two forces cancel each other. These two forces cancel each other. Hence, we can say if force is experienced by AB and force is experienced by CD also. I can write FCD equal to again I into L into B. But these two forces are equal but opposite, and they are acting in two different lines of action. Hence, they must constitute a torque.